The next property is commutative property. What is this? And this is very simple. Commutative operation. So for example, this hash is commutative operation. When can I say that this is commutative operation? This is commutative operation if and only if A hash B, this is equal to B hash A. Actually, this is the most easy property. Commutative means they can commute. Basically, here I can say that A comma B commute. Means their order does not matter. A hash B, that is same as B hash A. This is the definition of commutative. Okay, for all elements, this should happen. So if you have this set you have and this operation you have, okay, it's a commutative. When can I say this is commutative? This commutative if and only if for all elements this should happen. For all elements in S, what should happen? That A hash B, this should be same as B hash A. Okay, so for all this should happen. Now, what are the examples? For example, set of natural number comma plus. Is this commutative? Is this commutative? Yes, because you know that A plus B is equal to B plus A. So this is commutative. What about set of natural set of integers comma subtraction? What about this one? This is not commutative. This is definitely not commutative because 5 minus 4 is not same as 4 minus 5. So this is not commutative. Set of natural number comma multiplication. Yes, this is commutative because A multiplied by B is equal to B multiplied by A. So these are some operations which are commutative and the commutative and not commutative. For example, set of real numbers, real number minus 0. Let's remove the 0. Division. Is it commutative? Is it commutative? This is not commutative. Again, this is not commutative. Set of real number minus 0, non-zero real number. Okay, non-zero real number. So division operation, this is not commutative. So this is the idea about commutative property. This is the most simple property. So we have seen this property: associative, commutative, identity, inverse. Identity element is always unique, right? But remember, inverse element may not be unique, correct? I have already given you one example. Inverse need not be unique. You can have more than one inverse, but identity element is always unique if it exists. Either it does not exist, either there is no identity element. For example, set of natural number comma addition, there is no identity element. But if there is identity element, then it will be unique. You can never have more than one identity element. The classification of structures according to the property, which property they satisfy, according to that you can classify the structures.